Hello, everybody. Welcome back to our class on ethics and science. Today, we are talking about climate change. This is lecture 21. It is part one of our look at ethics and science for climate change. How do we look at climate data? How do we make policy decisions? And I have a few slides. I also just have resources I want to show you that then I would hope you look through yourself. And so I'm going to have a big list in our Canvas page here. You usually find these lectures through the Canvas page, so you've seen that list. This is not all required reading. It's stuff that I think you might find interesting. Originally, we had an extra reading for the week to tack onto our textbook that dealt with how the Trump administration is changing our view of scientific truth. And, it worked for the last person who taught this class because it happened to be taught during that particular administration. But we have a new government now. We're not going to deal with any of that. So let me share my screen and we are going to get into it. Let's start talking about climate change. So, where are we? That's the save button. There we go. So once again, we are talking about the moral genius of Michael Bay, right? No, not at all. We are talking about the climate. Here's a fun little meme relating to a problem that we all had to live through. And first, let's do a brief history of climate science and climate policy. So way back in 1896, a scientist by the name of Arrhenius noticed the math on rising temperatures for the planet. Then, nearly 100 years later, the UN established the IPCC, the Intergovernmental Panel on Climate Change. In 1990, the US established the Global Change Research Program. In 1997, various countries got together for the Kyoto Protocols as a way of trying to reduce their carbon impacts to kind of curb climate change. Back then it was called global warming. Sorry. And then we kind of realized that it wasn't going so well because in 2006, Al Gore released his movie, An Inconvenient Truth. 10 years after that, we had the Paris Agreement, which the US has left and then rejoined. The Kyoto Protocols and the Paris Agreement have been these international agreements to reduce carbon emissions, to embrace new technologies as a way of lessening our impact on the planet. Overall, and this is an oversimplification, they have not yet been enough. That's one of the reasons we had the Paris Agreement to replace the Kyoto Protocols, because it was realized that the agreements we made weren't actually fixing the problem, and most countries were not living up to their end of the bargain anyway. So let's maybe stop here and say, well, what is climate change? Because this is something that confuses people. Climate change is, if you want to have an overly simplistic way of thinking about it, climate change is weather plus time. It's not the immediate weather you have. And this is where people who would be skeptics or critics of climate change would often say, but it snowed, and so the world's not getting warmer, right? Well, no. It's about the patterns of weather over long periods of time, which includes hundreds or thousands of years. And of course, over those amounts of time, the climate has changed. Even without human influence, the climate would change. But when we're talking about climate change, we're of course not just talking about natural climate change. We're talking about climate change that begins with human action. The big scientific term for it would be anthropogenic climate change. And is it just global warming? Well, no. We could say that the Earth is overall getting warmer, and some of the maps we'll look at will show that. But it's more that weather is getting more extreme as the climate changes. It results in the world being warmer, but things like severe weather events in northern Texas are actually results of climate change. And so for the best information, you kind of want to look at regional climate models. And this usually comes to us from governments, universities, and the military. So let's actually look at a couple of these. And I have some cool sources for you. So this first one comes to us from the University of Wisconsin-Madison. And why Wisconsin? Because I happen to know more about the models for Wisconsin because they were part of a paper I wrote. And so, universities will put out some really cool stuff here. Here's historic trends from 1950 to 2018. And so let's look at, change in summer precipitation by percentage. I used to live right here. And so you can see there's been a slight change. There's been less precipitation in this place, but over in southern Wisconsin, there's been more precipitation. Oh, sorry, percent change. Yeah. And then, if you want to look at other models, let's see. That's more for Wisconsin. Again, there's some cool resources that that particular state has put out that looks at, well, what are some solutions we can have? What are some what are the impacts for this particular state? Because that's really what matters, right? We want to look at how is climate change going to affect this or that location, because that gives us real data and ways that we can maybe make meaningful changes for our local area. More on Wisconsin. Oh, wait, where is it? Here we go. No, trying to find. I've got too many tabs open. Okay, so here's a cool one. This is a project that comes to us from the University of Maryland. And what it does is that this is an aggregate of various climate models. So you can type in wherever it is that you want to look at, and it'll tell you how much, what the weather will feel like in 60 years. So let's look for a minute at, say, my hometown, Chicago, Illinois. So in 60 years, the weather in Chicago is going to feel like a typical day in Lansing, Kansas. What about Denton? In Denton, Texas, a typical day is going to feel like a typical summer day in Sabinas, Mexico. And then let's see. Let's try another one. Let's try Duluth, Minnesota. Duluth, if you've never been, is a wonderful but extremely cold city. And so the weather in Duluth is going to be a little bit more like the winter in Oregon, Ohio. And so this is helpful. Typically, whatever place it's going to look like is somewhere a little bit further to the south. Let's try somewhere else. Let's see. This is where the part, if we were all together, I'd ask you to name cities and we'd look them up and we'd have a good time kind of seeing what life is going to be like in the future. Let's try Miami. Miami, Florida. So for high emissions, Miami's climate in 2080 will feel the most like San Blas, Olimpa, Mexico. Okay. Let's try London. Doesn't have England. Oh, this is just for the US. Okay. So tools like this are really helpful. It helps you see what the future might hold in terms of climate. And the way that these are doing it, again, is by aggregating these local models. So if you want to see more local models, I encourage you to look at what local universities are putting out, like this Wisconsin Climate Initiative, or really what certain government agencies are putting out, like the Department of Natural Resources, Department of Fish and Wildlife usually have a good handle on this stuff because it's going to deal directly with the way that they regulate. And so what else do we have in this? Yeah, look at local and regional models. And then what about challenges to the climate consensus? Like we talked about in the previous lecture, there's a study for everything. There's a study to show that there's an opposing view for everything. So one, you might want to look at where that information is coming from. But beyond that, here's some decent challenges. People would say the global models are too large, which is why I was kind of showing you those local models that you can do a little research on your own for and poke around with. Typically, the best global models are the ones that aggregate together those local models. Then there's also this criticism that environmentalism has become something of a secular religion. It has its own orthodoxy. If you question it, you're considered a scientific heretic and you're unemployable. And, there might be some truth to this. We might also say that this argument is typically being made by people who want to tell you that their own religious convictions don't line up with climate science. And to that, we might say, and I think we'll talk about this next week, that there aren't really any religious positions that disagree with the idea of climate change when you actually break it down, that argument is kind of bunk. And then there'd be calls for greater evidence and responsible use of scientific power. People who would say, hey, let's slow down here. Let's make sure that we have the evidence correct before we start to take drastic actions. And that was probably a good argument in 1980, but over the last 40 years, I think we've probably gathered enough evidence. And then climate action is too harmful. And so this is a really interesting one. And this is one I will talk about more next week, that what do we do about the climate? And people are worried, they say they are anyway, that some of our actions might hurt the poor, and specifically the global poor. That, well, if we stopped doing things like producing oil, we're going to leave folks in these undeveloped countries living in an undeveloped state because you have to work your way up. And that seems like not a great argument. You could build clean power grids without first building dirty power grids. And if you want to look at sort of responses to that, I'd say look at the tips for climate action coming from people who actually care a lot about the poor. And two sources I would give you for that are, let me just pull this down so I can find it better. So here's one from the Catholic Church, Laudato Si. And this was a very long statement put out by Pope Francis about not just climate change, but environmentalism in general, care for the earth and how it is, care for people in need across the planet. Then there's also, where's the one from the World Food Program? Hey, yeah. So here's how the World Food Program, who recently won the Nobel Peace Prize, are dealing with climate change themselves. I'll give you the link to this website. But look, they're incredibly concerned about climate change, and they're not saying don't take climate action because they're worried that climate change is going to cause more problems. And so they have all these little publications they've put out about climate action. What do we need to do? How much worse are things going to get in terms of food scarcity? And it's, not even just people who are concerned for the poor that are starting to think about climate action. Here's another one that I have for you. Amazon has pledged to go carbon neutral by 2040. Why? Because, Jeff Bezos realizes that you can't be the richest man on earth if there's no earth to be rich on. And so the consensus is there. Is climate action too harmful? Probably not. If you want to, we can talk about that a little bit more next week. Moving on. So disagreement on climate action. Now this is actually where it gets really interesting. So there are a number of ways that we can respond to climate change. And this is where we can say, yeah, we have scientific consensus that it's a problem. What we don't have is scientific consensus on what to do about it. And so we have a lot of different responses. There's the traditional environmentalist response, somebody like John Muir, who would say, look, John Muir's dead, so we're putting words in his mouth kind of, but people like the Sierra Club maybe would say, look, nature knows best. We just need to pull back on what we're doing and we'll be okay. And then there's the eco-modernist response, people like Bjorn Lomborg, whose little essay I will put there for you. I have it here in the PDFs I have open here, I think. Oh, I have so many open. Yeah, Bjorn Lomborg, The Danger of Climate Doomsayers, who would say, look, I'm going to give you this to read, but what he says, look, we're going to get through this. We close the hole in the ozone layer. Science will prevail. Then there's another view, which is the view of, say, environmental ethics, where, look, we need to treat plants and animals as moral subjects. It doesn't relate directly to climate change because climate change then becomes one issue among others in the environmental ethics framework. And if you're interested in this, there's 100 classes with UNT about it because this is what our philosophy department is all about. I would recommend a book called The Sand County Almanac by a guy named Aldo Leopold that sort of started the environmental ethics train. And then there's also the environmental justice wing of things, which would say that human justice is eco-justice. And really, Pope Francis kind of exemplifies that view. So if you're curious about that one, check out Laudato Si. It's interesting. And then other responses, we would have the Green New Deal, which is coming about in American politics. Then there's, action by Amazon. There's a lot going on here. What to do about climate action has not been a consensus, but a lot of things are being done. Another one I would give you, and I'll give you the PDF for this. It's a full book, so I don't expect you to read it. Right here is the Drawdown Review. This is from Project Drawdown, Climate Solutions for a New Decade. And it really gives a ton of potential climate solutions here. And the way they talk about it is, look, there's no one solution. They've done the math. What we need is a lot of solutions. There's no silver bullets. And so they break it down into, support sinks, reduction of emissions. It's the incredible amount of work being done here is fascinating. And so I'm going to give you those resources and hope that you look through them. I've lost it again. Aha, here we go. So, look, we just said it, scientific consensus is not translated to policy consensus, and we still have people in power who would say we need to do nothing. The common theological argument, and I don't want to get into it right now, maybe next week, is that a loving God would never allow this to happen. And again, that's not a great argument. Let's think about the ship metaphor from the previous lecture, that you can't rely on providence for a policy decision. You need to prepare as if the thing that you are worried about happening is going to happen. And then we also don't quite have consensus on the results of climate change. We know that it's happening. That's obvious. But how extreme it's going to be is a matter of scale. It depends on where you are. It depends on how mitigation goes. That the future is not determined. And so we have things like Bjorn Lomborg's vision of everything's going to be okay, don't worry about it, science will fix it. And then we have, let me find the article. That little share thing comes up and then I can't find what I'm looking for. Yeah, so here's one. This is a piece called The Uninhabitable Earth, and it's pretty long, but if you want to take a look at somebody who is a bit of a doomsayer on it, David Wallace Wells goes into all these ways where, should the worst happen with climate change, things are going to be terrible and it's going to be sooner than you think. And it's a compelling read. It's also a very depressing read. So, maybe make sure you're in the right state of mind when you're taking a look at it. But all that to say is that there are different models. If we look at, say, I have the IPCC report up here, which again is incredibly long. I would say that you should take a look at this summary for policymakers. I'm not going to ask you any quiz questions about it, but it is, for your own consumption, quite interesting. They kind of give these various models of, well, how bad is it going to be? What is happening with global warming at 1.5 Celsius? And let's see, we're jumping around again. And that's the global average. So some places it's going to be higher, some places it's going to be lower. And that this is likely to happen sometime between 2030 and 2052. They have high confidence in that with the math that they've done. And they kind of break down regionally what this looks like. I don't want to spend a lot of time looking at all of the regions on the planet because we don't have that kind of time. So then what are the types of climate action? And I'm sorry that this is a little bit scattered. I'm trying to give you as much information as I can as an opener. And then next week, we'll talk about some more specifics. But in general, there are 3 kinds of climate action we can take. Sip of coffee. So there's adaptation, which is we know that the climate is changing. And so we will change how we live. You look at things like green engineering or sustainable architecture, or people would even go as far as to say that you need to grow all your own food, become a vegan, that kind of thing. And then there's mitigation. We could say we can stop climate change by altering our practices right now. If we just made sure every car was electric, well, boom, we've solved it. That's an oversimplification. It would take more than electric cars. It would also take changes to agriculture, all that. Again, check out the Drawdown Review. They give hundreds of solutions. And then there's also the third one, which is geoengineering, which at the moment is a beautiful dream. And look, science is always developing. This is the holy grail for climate action, and it's definitely the one that the eco-moderns would prefer, where they would say we can reverse climate change through technology. Typically, the big technology that's hoped for here is carbon capture technology. And we have this already, it's just not quite working well enough that we could, in some way, set up these places that just suck all the carbon out of the atmosphere. The mitigation and adaptation folks would say, hey, we have that. It's called the tree. Why don't we just plant some of those? But there are also other forms of geoengineering. People have talked about, you know, putting this or that material in the atmosphere to reflect the sun better. But of course, it would change the color of the sky. And so maybe that's not a great idea. Solutions are available in theory. In practice, we're not so sure yet. Thinking in our last lecture about how things are different in the laboratory than they are in the real world, we might want to make sure that whatever geoengineering practice we try works and works perfectly before we actually put it into practice, right? And so I know that was scattershot. The point here is not to give you a definitive lecture on climate change. It's to give you some resources that you can look through yourself. And so, again, you're not required to read all the things that I'm going to give you. I want to give them to you as a way that you can educate yourself a little bit about it so that you can look at the question that we have for this week's post. So you have a task, and then you can answer the questions. The task is spend some time looking through the optional reading list and websites for the week, especially some local climate models. You can also go beyond my reading list if you want to find some for Texas. I did a little bit of research so far, and they are harder to find, mostly because the state of Texas has not put as much in terms of resources into looking at their own climate models. Other states have done a little bit better job of that. That's okay. You don't have to spend time with Texas if you don't want to. You can look at other states. You can look at your home state or another country if you feel like it. And then after looking at the information I've provided or information you can find on your own, answer the following questions. 1, what climate solutions do you see as the most promising? 2, how should national climate policy be determined? And then 3, how should international climate policy be enforced? And that becomes a really interesting question, right? Because it involves a lot more stakeholders than we're used to when making a decision about ethics and science with, say, an experiment or a vaccine trial where the stakeholders are a small number of people. With climate change, it's everybody who's alive or who might be alive. So that's what I have for you today. I hope you're doing well. I'm really excited to be into this sort of application period in our class, and we will get right back into climate change for policy again next week. And so I will see you all around.